Well, hey guys, Mr. Delcourt back again for a little more remote learning. We're talking thunderstorms today, and man, nothing gets me thinking about summertime more than thunderstorms, those evening storms that we have that tend to roll through. I'm hopeful that after today, we've got a little more appreciation for the science behind those thunderstorms, and it just adds a little bit of enjoyment, understanding maybe why that thunderstorm's happening and some of the physics behind it that we'll talk about here in a few minutes. So really quickly though, let's get down in our notes. Hopefully you've uploaded the note sheet to Notability at this point from Google Classroom. You've got that open, and that way you can flip back and forth as we go through this, and you can fill in your note sheet, and this will be helpful for you later on when you work on your CK12 assignment. So let's get right to it. Let's talk about what thunderstorms are. Well, we know a thunderstorm, we know part of their feature is that they form quickly. They can often kind of come out of nowhere if you're not paying attention to the sky. They drop a lot of rain. So they're known to drop a ton of precipitation in a very short amount of time. If they form quickly, but they also dissipate quickly. And some, as we know, can be severe. So we have some very severe damaging weather that can occur as a result of thunderstorms. We'll get more into that maybe next class as well. So let's think about, though this is the fun stuff here, let's think about thunderstorm formation. What's actually happening when a thunderstorm occurs? And here's why they happen most often in the summertime. Because the number one thing we need to get a thunderstorm to occur is warm, moist air. So let's put this here. They form when warm and moist air, high in humidity, lots of water vapor in the air. They form when warm, moist air collects along the ground. Or along cold fronts, and we'll talk about why that is in just a second. So they form when we get that warm, moist air collecting along the ground. When we think about a summer day here in Maine, I think about heat and humidity. There's lots of water evaporating off all our lakes and rivers and off the ocean, and we have a very warm, moist air all along the ground, and we get conditions set up pretty well for thunderstorms to occur. So right off the bat, let's think about, what does warm air do? We talk about this all the time in class. I ask you guys all the time, what does warm air do? And we know that warm air rises. And once it rises, that warm air, it then cools, and water vapor condenses into droplets. Those cooling droplets begin to fall, and what we get is, everybody's favorite, a convection current begins to set up. And let's draw that here, and let's think about exactly what's going on during a thunderstorm, specifically one that's happening along a cold front. So we already mentioned in our description a couple classes ago about cold fronts. We said we've got colder air here, and it's moving this way very quickly. That means this air here along the ground is warmer, and it must have lots of humidity in it. As that cold front plows along, kind of like a bulldozer or like a wedge, it forces that warm air upward, and that warm air rises, and as we know, when warm air rises, it cools off. All those water droplets begin to condense. All that water vapor begins to condense into water droplets. We get these big, tall cumulus clouds that are indicative of thunderstorms. We get all that water vapor condensing into a cloud, and then within that cloud, we've still got that warm air rising, and that cooler air up near the top of the troposphere there cooling off. And what do we get? We get these really strong convection currents going around and around. We actually get uplift that's strong enough in that cloud to hold rain droplets up in the sky. So you ever had a thunderstorm where the raindrops are just these huge, giant drops of rain? That's because there's such a strong updraft up there in that cloud that it's able to hold that moisture up in the air. It's kind of like, have you ever seen like one of those air blowers like suspending a ping pong ball in the air. I think of it like that. And in some cases, we form hail by doing that. If we can suspend that droplet of water in that cold air long enough near the top of the atmosphere and we freeze it, we can get hail. And we've heard stories of what baseball and in some cases softball or watermelon-sized hail. That all happens because of extremely strong updrafts that are holding that frozen chunk of hail up in the sky. So really cool stuff. Eventually, though, that convection current weakens, and when that happens, we end up with, let's see if I can get this to work. When that happens, we end up having those droplets fall down to the ground. So let's talk about lightning and thunder. Let's see if I can get I think my Apple Pencil just died on me, so we're going to have to go old school here. Let's talk about lightning and thunder, which are absolutely, critical components of any good thunderstorm, hence the name thunderstorm, right? Lightning and thunder, we said they release, I'm going to go smaller on my font here. Let's go down to 14 here. They release large amounts of electrical energy from a cloud. And there's actually still some debate about what causes lightning. It's kind of crazy, but scientists still really don't fully maybe understand the whole deal. It's kind of cool to think about that there's still stuff out there that we're like, I don't know. Yeah, lightning, it's one of those things. It happens, and here's why we think it happens, but we're struggling to really prove it, okay? But let's think about one of my favorite parts about lightning and thunder. Some physics involved here, some easy stuff to conceptualize. This idea that we often see lightning before we hear the thunder, right? So what's going on there with lightning and thunder? Why is thunder so loud? Thunder is caused by the rapid expansion of gases around a hot lightning bolt, right? So that lightning bolt is super hot and it causes the gas around it to expand rapidly, and expanding gas we know causes a loud sound. I think of things like a popping balloon. If I've got a balloon that's, got air that's condensed really in tight around it, we pop that balloon in the air, expands very quickly. Guess what? We get a loud noise. A gunshot is the exact same thing. We've got hot gases burning when gunpowder combusts, and when those hot gases expand out the end of the barrel, we get a loud bang. And the same thing's happening with thunder. Now, why then do we see the lightning and then hear the thunder? That happens because light, as we all know, travels faster than sound. So when when a thunderstorm is far away, we'll see that lightning, and it may be several seconds before we hear the thunder because that light has gotten so far out ahead of the sound. Now, when that thunderstorm is very close, I mean real close, there's no discernible difference, right? You may see a lightning strike and hear it essentially the moment it happens. That's when you know you're really close to a thunderstorm. So just interesting stuff. Hopefully you've been following along today. Make sure you're pausing, if I'm going too fast, so that you can get all this stuff in your notes. And make sure you head over and do your CK12 assignment on thunder.